Hi, this is a pure sine wave inverter which has been designed to reduce the conversion loss. In the most of the commercial inverters, which are not pure sinusoidal in nature, we see that there is conversion loss from DC to AC. Especially in modified sine wave inverter, there is a huge loss of conversion. Therefore, we cannot utilize the DC voltage in the form of AC properly. But here we have used a microcontroller which produces a passive modulated signal. The PWM signal in the form of a sinusoidal wave is feed from this point. These are the buffering circuit in order to strengthen and remove noise, and also these are the RC filters which are used to reduce the noise significantly. And then finally, the signal is fed into the NAND gates, and the NAND gate and the signal is feed into the MOSFET driver. MOSFET driver is used because the input on the signal from NAND gate is too weak for the MOSFET to drive directly. Therefore, the MOSFET and the drivers actually strengthen the signal to sufficiently drive the number of several number of MOSFETs. Here, several MOSFETs are connected in parallel to increase the capacity of the inverter. If we want to make a large inverter, then we have to multiply the number of parallel connected, increase the number of parallel connected MOSFETs, which are driven by the same gate signals. This circuit is used to produce the positive half cycle of AC signal, and the lower part of the circuit is used to produce negative one half cycle of AC signal. And this is the battery positive terminal, and this is the battery negative terminal. That is, we have to connect the battery positive terminal to this point and the negative terminal to this point, and the output pure sine wave output will be collected from the midpoints of the MOSFETs, and here the output and the signal will be that is 12 volt AC, which need to be increased to 220 volt. Therefore, we have used a transformer, step up transformer, and in order to eliminate the noise of the AC signal, we have used a LC circuit. I have designed the PCB of this circuit in this phase. This is the PCB circuit representation, PCB design, and this is the visual representation of the circuit along with its components. So after implementation of the circuit, uh, the design will be like this. Thank you.